Okay, so today we're going to be looking at solving exponential equations using logs. Okay, so to start, we've got a pretty simple example here. We've got 2 to the power x equals 7. And the instructions say to solve this using logs. Now we can't do what we did in the warm-up here because there's no way to make the bases the same. Okay, this is a base of 2 and this is a base of 7. Well, 7's not a power of 2, so not an even power of 2. So it's not a perfect power of 2. So there's no way to make the bases the same because this is 2, this is 7. It's just not going to happen. So we need some other method to solve this than trying to make the bases the same. So what we're going to do is we're going to use the inverse property of logs. Okay, logs can cancel out a base number because what we're trying to do is we're trying to figure out what this is. So what's really in the way here is this 2. Okay, this 2 needs to go. So to get rid of this 2, we are going to take a log on both sides. We're going to take the log of both sides. Not just any log, but the log that matches what we want to get rid of. Okay, so we want to get rid of this base 2. So on both sides, we're going to take the log base 2. Okay, so what does it look like to take the log on both sides? Essentially what I'm going to do is I want to get rid of the 2, so I'm going to take a log base 2, and I'm just going to do it on both sides of the equation. So the left side of the equation, log base 2 of 2x, and then the right side of the equation, log base 2 of 7. Yeah. Why is it base of 2? Because what we're trying to do is get rid of this 2 here, and the inverse property of logs says that a log that has the same base as the exponent can cancel each other out. So essentially what we're doing in this next step is we are saying log base 2 cancels out a exponent base 2. We'll get to the 7 in a second. So on the left side, all that you're left with is this x because the log base 2 cancels out the exponent base 2. So that's gone. So you have x. On the other side, you do still have log base 2 of 7. Now this equation is solved. We just don't know what the solution is because we don't know what log base 2 of 7 is. Okay? So what we're going to have to do is we're going to have to use the scientific calculator to figure out what log base 2 of 7 is. Okay, so let me get out the scientific calculator. Why did that happen? Should be back in a second. Okay. So what I'm going to do is I didn't even touch it. I don't know why I did that. What I'm going to do is I'm going to get out the scientific calculator. No internet. Okay, so at this point, what I'm trying to do is I've got x is equal to log base 2 of 7. I want to put this into the calculator, but you'll notice that there is no log base 2 button. There's a common log button and a natural log button, but there's no log base 2 button. On the graphing calculator, there's a log base 2 button, but not on the scientific calculator, which is what we have to use to solve this. Okay, so how can I figure out what log base 2 of 7 is using the scientific calculator if it doesn't have a log base 2 button? Does anybody remember? We went over how to do this a couple days ago. How to calculate something like log base 2 of 7, yeah. Scientific. Do what? That would be for graphing. Correct. So that's the change of base formula. You're correct. So we have to use the change of base formula. Change of base formula allows us to turn it into a fraction of common logs that we can then type into the calculator. So this is going to become common log of 7 divided by common log of 2. And now using this, we can figure out what the value of the solution is. So I'll go ahead and put that in my calculator. Common log of 7, common log of 2 tells me that my solution is about, remember to round to 3 decimal places, so 2.807. Okay, and that is the solution to my equation. So if you look back at what the equation was asking, it was saying 2 to what power is equal to 7? And we answered this question. 2 to the power of 2.807 is equal to 7. Okay, so this is the power of 2 you need to make 7. It's a little bit lower than 3, which makes sense because 2 to the 3 is 8, and we're trying to make 7. Okay, so the main idea with solving these is remembering, take a log of both sides, but also remember to use the change of base formula so that you can do the calculation. All right, let's take a look at another one. Any questions on this one before we move on? So let's take a look at another one that's a little bit more complicated. It's going to have just some more stuff added to it. So let's say that it's a base of 7 and that the exponent is something, it's still got to have x in it or else it's not exponential. So the exponent has to have x in it, but let's put some more stuff up there. So like x plus 3. All right, and now let's add some more stuff over here. So let's do like minus 6. And then on the other side of the equation, we can keep it simple. Let's just do like 20. So this is an exponential equation. The variable is in the exponent, so that's what makes it an exponential equation. Our goal is going to be to get what the variable is. So you kind of want to treat this like a normal equation. You just have to be sure that when it comes to getting rid of the base number, that you use a log to do it. Okay, so any ideas on what the first step of this equation to solve it would be? Sorry? Okay, yeah. So the 6, really what we're focused on is this 7 to the x plus 3. So this 6 does not need to be here. So let's move this over. Okay, so now we are at 7 to the power x plus 3 is equal to 26. All right, so what do we want to do now? So we're so close because what we want is this, and the only thing over here in the way is this 7. So what are we going to do now?
Log both sides.
Good. Log both sides with the base of 7 because we want to get rid of that 7. So I'm going to do a log on both sides to get rid of that 7. So log base 7 on the left side, 7 to the x plus 3. On the right side, log base 7, and that's 26, or of 26, I should say. Okay, this is the right step because the 7 is what we want to get rid of, and this log is going to do that. This log will get rid of that 7. So log base 7 cancels out the exponent base 7. So all that we're going to be left with is this x plus 3. Okay, so let's take a look at where we are now. We have x plus 3 on the left side because the 7's gone. On the right side, we have log base 7 of 26. Now, unfortunately, we're not solved for x just yet because it says x plus 3. However, before we go any further, it's going to be useful to get a number for log base 7 of 26. So let's go ahead and get a number for log base 7 of 26. Okay, so how am I going to figure out what log base 7 of 26 is?
You gotta change what's your
Right, change of base, correct. We got to use change of base. So we got to do common log of 26 over common log of 7 and see what this is. Okay, so this we'll need the calculator for. So common log of 26, common log of 7, 1.674. Okay, so this is 1.674. And then on the other side, we still have this x plus 3. Now we are almost solved here because the x is like so close to being by itself. We just got one step remaining and then we would be finished. So if we're at x plus 3 equals 1.674, what is the last step here to get x? What's our last step here? Minus 3, correct. We want to get this x here. This plus 3 is in the way, so we're going to minus 3. That thing needs to go, so we're going to minus 3. Okay, so once again, we're going to need our calculator, unless you know what this is. 1.674 minus 3. So 1.674 minus 3. Do what? Yeah, 1.674 and then minus 3. It should be negative.
Yeah, it should be. That's what
Negative 1.326. Okay, so we get a solution of x negative 1.326. Okay, so this is our solution to our equation, and we used logs. This was an exponential equation that we used logs to solve. Okay, so these are very similar to just normal linear equations. You just have to remember that one step of how to get rid of that base number, and you get rid of that base number by using a log. You also have to remember how to evaluate that log, which is change of base. Yeah, just a minute. Are there any questions about this problem here? Okay, so let's try some on our own. So let's go ahead and take a look at these two on the next page. We have 2 to the power x is equal to 5. This is very similar to the first problem we went over, so this one should be pretty straightforward. We have a little bit more complicated one for number 2. 7 to the power 9x is equal to 15, but both of these you do essentially the same way, solve them using logs. So go ahead and try these here.
This one, I know it's another.
Yeah, 1 second.